As in the previous example, we want to take this equation for an ellipse and complete the square to rewrite the ellipse in standard form and then sketch its graph. So let's begin by grouping our terms that involve x, 16x squared minus 32x. And then we're going to group our terms that involve y, 25y squared minus 50y. And then we're going to move our constant to the other side of the equal sign. So as we did in the last example, we're going to have to factor out the term that precedes the squared term. So if I divide by 16, I'll have x squared minus 32 divided by 16 is 2x, plus, in this term, we're going to have to factor the 25 out, and that's going to leave us y squared minus 2y equals negative 16. And now the process of completing the square. We're going to take half the coefficient of 2, which is 1, and add in a 1 squared, plus 25 times y squared minus 2y, and again half of 2 is 1, so we're going to add in a 1 squared, equals negative 16 plus 16 times 1 would be 16, and 25 times 1 would be 25. So our equation is 16 times x minus 1 squared, if we factor our trinomial, plus 25 times y minus 1 squared equals 25. And so to get our final format, let's go through and divide each term by 25. And so in standard form, our ellipse is going to be x minus 1 squared over 25 sixteenths plus y minus 1 squared over 1 equals 1. Now this looks a little strange with the fraction, but we're going to need to write it that way for the rest of the problem to make sense to us. So now we want to graph this ellipse, and we can see that the center of the ellipse is 1, 1. Horizontally, we're going to take the square root of 25 sixteenths, and the square root of 25 sixteenths is 5/4. So we're going to move 1 1/4 to the right and 1 1/4 to the left to get our horizontal vertices. And then we're going to move up 1 and down 1 to get our vertical vertices. And so there is the rough sketch of our ellipse. I noticed that the center of this ellipse was, as we said a moment ago, 1, 1.